Today we are going to talk about the dependency injection. So first of all, we will go through some standard coding, but we would have written. You can see there is an interface, my service. There is a method, my method, and that is being implemented by my service intel. And there is a client application which uses this service. So what we have done here is we are defining the interface and then we initiating the object my service simple there. So in this case we are losing the important idea why we are using the interface. So the idea behind the interface is to abstract the business logic away from the code. So the client only needs the interfaces and the method. The actual implementation they don't want to worry about. But in this case we are directly coupling the implementation with the client side. Client call. There is a client and a service. The service is there. It will be there, but the client should call the service and get the service be done. So what will happen if this service is changed? For example, in the above code I showed my service simple. There can be another implementation of the same service, my second service simple. If that case, we have to say the client, okay, the service impl class is different now, so use this service, yeah. It is a bit cumbersome, and if there is one client, then okay, we can simply go and change the client, but in the scenario, there can be multiple clients. So one service is reusable, so it can be reused by more clients. So in that case, we have to go each and every client and say the implementation is changed, use this, use this, use this. Of calling the services. So that is where inversion of control mechanism comes in. Inversion of control is simply inverting the control. So after this, the client will not call the service, but the service will call the client. So the client don't know about the service, but whenever the service is needed, service will be there without the client being called. Control. From the Wikipedia, it describes the design that custom written quotients receive the flow of control from the reusable library. Reusable library is the service. So the client code gets the control from the reusable library. So dependency injection is one of the application of inversion control actually. So the dependency injection is injecting the dependencies. So simply saying dependency injection is injecting the dependencies. So there can be a client, and if the client can use multiple services. So these each services is being injected in the compile time or runtime. So it can be simply changed with the simple configuration. It creates loosely coupled modules. As the above example, the client code is directly coupled with the implementation method. If we abstract the implementation away from the client code, it is not directly coupled. It's loosely coupled, and it create the maintainability. It will be there if we are actually using in the real world scenario. I will show you an example later. And it reduce the boilerplate code. So we don't want to initiate objects each and every time. So we can simply use some annotations and all the things will be done automatically with one simple code. And it can also create the independent development. In the above example, the implementation is directly coupled with the client code. So one person may implement that implementation service class and one person may implement the client. So they should know each other because it's tightly coupled. If the dependency injection is there, the person who is writing the client code does not want to worry about the implementation at all. He just simply injecting the interface, never worry about the implementation name or anything, and just use it. So dependency injection, actually we don't need any other framework to get injected. We can simply change the code. So this is the above code, but it's changed. So in this case, what we are doing is in the first part, constructor injection. So the client, when the client is being instantiated, we pass the service as parameter. So they are no longer the implementation is there. My service simple is no longer there. It's gone. When we create the client, we pass the actual implementation in the constructor injection, and we can also use the setter injection injection where we create the my client first and then we can set the my service. But here we have get aside the implementation from the client's code. But who is going to set this constructor? Again, we have to call this constructor, right? Wherever there can be a main method, and inside the main method we are going to initiate the client, my client. So in that case, we have to again pass this my service simple as the parameter. So that is where frameworks comes to help us. Of the framework we can use to inject the dependencies, Google Guice, pronounce it as Guice, and it is an ultra lightweight dependency injection compared to the most prominent dependency injection, Spring, and it is created by Google and maintained by Google. It is type safe and configuration based dependency injection, contrast to XML based dependency injection in the Spring. So when we are going to inject the dependencies with the Guice, we have to follow simple 3 steps. First, there is a modules class interface actually. We have to implement that modules class, and then we should define the bindings like we are doing in the Spring XML. We have to define the bindings. So this interface matches to this implementation class, and then simply use some annotations. First, I'll go through each of the ideas behind this Guice. First, we'll go through the bindings. Binding is an interface. Binding interface which gives methods to bind interfaces in the actual classes. So in the example, you can say binder bind my service class, binder bound to my service interpreter class. So this is the binding we have to do. That's it. And we can use my service simple.class class name, or we can simply initiate a new object inside that, like in the second step, new my service simple. Or else, if for some time we may need more complicated objects. So the default constructor may not be enough. We may have to do some pre-processing before initiating the object. In that case, we can create custom providers for those services, and we can simply bind the interface to those providers. So whenever this service is called, that provider will create the object and will return. And the default scope in the Guice is new for it creates new instance for each call. It's contrast to the singleton idea behind the Spring. So in the Spring, the default will be the singleton services, but in the Guice, it creates each and every object for each request. So, but still, we can define the scope in the Guice. And also, this lazy loading, Guice is actually, so whenever the service is called, only the object will be created and loaded. So in contrast, we can say as eager singleton, which creates the object in the runtime before calling the actual service. The second class is Injector. So we have these bindings defined, and Injector is the class which get the instance from those bindings. So Injector objects we have to create Injector.getInstance, and then simply pass our class, and then it will create the myService class object. It may look some complicated, but this code should be written in one single place. So we don't want to create a new instance each and every time, but on one single place we have to get instance from this Inject object. And then the important class is modules. Modules is an interface which have these all bindings inside, and it is implemented by another class, abstract module. So the module developers can actually extend this abstract module and implement this configure method. So inside this configure method only we are going to define these binders, what we earlier discussed. So abstract module has a binder, so we can simply use that binder object and bind the services to the service impulse. there is one singleton static class Guice. So that is the overall controller. So this is where we are passing the modules where the bindings are and create the injector. So Guice.create injector, and then you have to pass the module where the bindings are defined. So this is where the injector is created, and with this injector we can get the objects by passing the Guice is injected and used by the annotations. It's type safe, so the Java configurations that are there and annotations are there. That's it. So the main annotations we are going to use here is these four. First one is the inject, very similar to the AutoWire if you are familiar with Spring. So this is used to inject the objects to the code. So it's just a matter of adding the inject and define the service. That's it. So it supports, it prefers the constructor injection, which is again contrast to the Spring setters injection. And we also can define method injection and field injection. Another annotation is implemented by. So we earlier discussed about these bindings. Say we have only one interface and one single implementation of that. So we don't want to actually bind these all things. We can simply say implemented by in front of the interface, implemented by, and then define the actual implementation class. So it will implicitly create that binding. And we can again say the singleton. So we have to simply annotate the singleton in front of implementation service classes, and thereafter Guice will create only one single instance of those service input. And finally the provided by, as I said earlier, we can specify some providers to create the instances for us. So in that case we have to define this provided by and specify which provider is going to provide this instance. So how we are going to bootstrap this Guice application? As I said earlier, there should be one main object which uses the injector and get the instance. And thereafter, recursively, all the injection will be done automatically. We don't want to create anything, but in the main method, we have to create at least one object using Guice injector object. It has a student object, which is just a model object, and student store interface, which has these methods: student exists or not, student loading, implementation of the interface, and we have another implementation of student store there, which registers the student. It stores the student and retrieves the register object. So this has been done in the conventional way, but we have been done. So we are creating new object of, as you can see, store as well, store implementation object as well. So we are creating two new objects here. To this, first we have to add the dependency, or else we will have to download the jar and add it. Since this is the Maven project, I'll simply I have removed the null check there. So we have to make this instant singletons, or else if we run this code, ID is 10, it's got saved. If we again enter the ID, it's getting saved because as I said earlier, the Guice will create each instance for each call. So whenever we call this injector.get instance, it will create a new register class and return to us. So what we are going to do is, we should define this register as a singleton. We can do in two places, either here, as here we can define the scope, fine as expected. We enter the same credit, use already exists. So now it returns the singleton object for each call request. And let's say if we are going to use this another student store which has a simple additional checking there. I added. It checks the credits as well for the students. We are entering this credit, and if the credit is less than 10, it will. So this is simply applying the juice to some modules. So as I said earlier, we have to create one object using the injector object of the juice, or else it's not getting injected. So this code should be there in the main class, and after that it will recursively inject all the things with the inject annotations. Basic idea about the juice. So we can do some more with the juice. First, we can bind multiple implementations to one interface. So let's say in the above example, we have two implementations of the same student store. So in that case, we can create custom annotations. Like in this case, we are using annotated with blue dot class, annotated with green dot class. So whenever we are annotating, so example is given. So the rest is same. At inject service is there. In the middle, I have added another annotations blue. So with this annotation, it will search for the annotated by there. So in the bindings we have specified if it is bounded to the blue annotation, then use the blue service. Or else we can simply change this green to bind to another service. So in this case we can, and here we have created these blue and green annotations. So in the Java we can simply create the annotations like this. I think you all have been familiar, or else it's a common method to create annotation. So the retention runtime, it means it's visible to the runtime, and where we can use this where we can use these annotations. In this case, we can use this for field and parameter, and it's a binding annotation. It's only the binding annotation. That annotation is the Guice specific. All the things are Java specific. And using this binding annotations, we are specifying these annotations is used to bind some interfaces with the implementation. We can use some more annotations, like in the early case I simply create at blue only, and we can create annotations with the values, with parameters. For example, in the earlier example I created blue and green. Let's say we have to have multiple annotations, blue, green, yellow, red. Then in that case we can simply create one single annotation called color, and then we can define a value. Then we can pass the strings as parameters. So based on the string value, each class will get injected like this. It's a named annotation, so it has a value. So we are binding the person class with named annotation Bob. So whenever we are injecting at named Bob, it will bind to the Bob class. Likewise, we can pass any strings there. Here we can create objects through the providers. For example, here we are going to inject the money, but we have to get two objects. So what we can do is we can directly inject the providers, not the objects, the providers. And inside the methods, we can use these providers to get the objects. So here we are injecting the provider ATM, and through the ATM we are receiving objects multiple times. As in Spring, we can also bind constants like this. So we can create the annotation the answer, and we can simply inject the answer into answer, so it will automatically get instantiated with the value 42. So we don't want to. So in this case, we can have reusable configuration values, and this is a sample code of the provider. So what we can do is we can create any provider by implementing the interface, the generic interface provider. So the provider passing the object, and we implemented that, and inside that there is a method get. So we have to override that method to return our need. So in this case, we can, so here, actually we are getting a widget class. So we want a widget class, but inside that, it is using another service, right? So what we are doing is, through the providers, we first inject that service to the object and then create a new widget. So we can simply bind the interface with the providers. In the earlier example, we directly bind widget class to some implementation. So we can simply change to provider and then provide the provider class. Finally, we can use AOP concepts with the Guice. So we can intercept the methods, which is very popular nowadays. We can create interceptors, just like we did earlier. We can create annotations. So here, transaction is an annotator, and we can implement. There is a class method interceptor provided by Guice. So we can simply implement that interface, and we can write our own code there. So whenever this transactional annotation is there in our code, it will first go to that interceptor and do the logic, and then only the actual method. Some advantages using the Guice. So we already know the string dependency injection. So it is a full stack web framework. So we may not need that kind of big, large dependency injection in our code. So Guice is very lightweight. It's only specialized to do dependency injection only. And another important plus point in using Guice is it's type safe. Spring has a Java config where we can use Java-based configurations, but that is not widely adopted yet, as I know. But here in the Guice, all the things are done using the Java-specific code. It's type safe and annotations. That's it. And if you are going to use some dependency injection for Java, Guice is definitely the first choice because it is specialized for Java. And it has simple life cycle than the Spring one. So, which means it increases the performance. And another important one I have also noticed, and many people have mentioned this, it gives meaningful errors. Whenever there is an error occurred, I have experienced, as in my experience, the Spring debugging is very hard in auto-wiring cases. So injection, there can be errors, so it's hard to debug. But Guice, it gives very specific error, very detailed error. And it's less complication because we don't want to have any XMLs or anything. As I have done earlier, one single abstract class, we have to extend that, just binding the classes and simply call the inject, that's it. Which again gives us a clean code. There is no extra classes, the XMLs, only the Java classes, and very clean. Disadvantages as well. In my experience, I experienced that it's hard to inject the third-party dependencies. For example, we have to explicitly say at inject everywhere where we want to inject the objects. Say, for example, we are using another third-party application which we don't want to change its code. Inside that, it can have some object instantiations. So in that case, we can use this Guice. Actually, we encountered a problem in the repository as well. So it should have that explicitly inject annotation. That is one of the main problem with the Guice. And as I said earlier, it's a bit cumbersome to inject the literals, the constant values. It's very easy with the Spring one, but here it's little bit complicated. That's it from my presentation. So, any questions?